Hi, this is our second video in the nuclear chemistry unit, and this is going to be about half-life. So half-life can sometimes be represented as a T with a subscript 1/2. So I hope you're familiar with these equations, but this is thorium-234, and it's undergoing a beta decay to form proactinium-234. And so we worked on balancing these nuclear equations. But what's really happening here, let's say that we started with, 100 grams of the sample. If we start with 100 grams of the sample, after 24 days, we would have 50 grams of the sample. And then after another 24 days, we would have 25 grams. And after another 24 days, we would have 12.5 grams. So the half-life for thorium-234's decay is 24 days. And so how is half-life defined? Well, it's defined as the time it takes for half of a sample to decay. If you're a visual learner, you may like looking at a graph to see what this looks like. And so if I'm looking at the amount of 234 over time, and my amount here is on my y-axis and time is on the x-axis, you start with an amount and then this time would be 24 days. After 24 days, the amount is cut in half. Another 24 days and half again, another 24 days and half again. Now, half-lives aren't always in days, it can be in minutes or seconds or even years. So half-lives can vary greatly. Well, let's go ahead and look at another radioactive decay equation. We've got radium-223, and it undergoes an alpha decay to radon-219, and the half-life for this is 11 days. If we started with 200 grams of radium-223, how much would be left after 33 days? Well, I like to just start with a chart. So I'm going to start with 200 grams, and after one half-life, it would go down to 100 grams. But how many half-lives is 33 days? To figure that out, we're going to take 33 days, and we're going to divide it by 11, because that's what one half-life is. So 33 days is 3 half-lives. Well, this is one half-life. We've gone to 100 grams. Well, if we do a second half-life, we would have 50 grams remaining. And then if we went to a third half-life, we would cut that 50 grams in half again. We would have 25 grams. So after 3 half-lives, we would have 25 grams remaining. And so that's the answer. If we started with 200 grams of radium-223, after 33 days, we would have 25 grams left. Now, sometimes these questions are asking the very same thing, but they might be worded slightly different. They might say something like, what percentage is left after 33 days. So they might not just say how much and want a gram amount, they might say what percentage. And actually, I kind of think this is even easier. Okay, so it is still 3 half-lives. 33 days is 3 half-lives. We would have started with 100%. 1 half-life would be 50%. 2 half-lives would be 25%, and 3 half-lives would then be 12.5%. So again, make sure that you're decreasing your percentages in half each half-life. So 50, then 25, and then 12.5. So that is 3 half-lives. The answer would be 12.5% would be left after 33 days. I've also seen them use fractions when they're asking these questions. And so they might say, what fraction is left after 33 days? So let's put in the word fraction here. And again, we're going to use the same problem, and we have 3 half-lives in 33 days. So here we have 1 and then 1 half-life. We would have half. And then after a second half-life, we would have another half. And after a third half-life, we would have another half. So 1 half-life, 2 half-lives, 3 half-lives. You put those all together and we have 1/2 times a half is a fourth, times a half is 1/8. So the answer would be 1/8 the amount would be left after 33 days. All right, what other ways can they ask questions to use this concept of half-life? So here is another way they can ask the question. They could say the half-life of I-131 is 8 days. If you start with 100 grams of sample, how long would it take to have 12.5 grams of it remaining? Or they could have asked for 12.5%, or they could have asked for the fraction 1/8. So here they're asking for how long it would take, not the amount. And so we're going to use the exact same process to solve this problem. So we are going to start with 100 grams of the sample. And we want 12.5 grams remaining. So if we start with 100 grams, 1 half-life would take it to 50. 2 half-lives would take it to 25. 3 half-lives would take it down to 12.5 grams. And so 1 half-life, 2 half-life, 3 half-lives. It would take 3 half-lives for our I-131 to go down to 12.5 grams if you had started with 100 grams. Well, each half-life is 8 days. It took 3 half-lives to get down to 12.5 grams. So how long? Well, 8 days is a half-life. It took 3 half-lives. The answer would be 24 days. Okay, if they wanted to know to have 12.5% remaining, we would just do the same thing with percent. We would see that to get down to 12.5% here, it would be 3 half-lives. The answer would be 24 days. Or 1/8 of it, you would have said 1/2, another half. That is 1/8, which would take 3 half-lives, times 8 is 24 days. All right. Now, again, they're not going to ask you, how long, or what percentage, or what fraction, all in the same question. But I'm trying to pose a question in all the different ways conceivable that you may see the question asked to you. All right. The last thing I think they're going to ask, or that you could be asked to do with half-life, has to do with you telling them the half-life. So they'll give you a little bit of data, and now you have to calculate the half-life. So technetium-99 is used in brain scans. A lab receives 200 grams of this isotope. After 24 hours, only 12.5 grams remains. What is the half-life? So let's go ahead and see how many half-lives have occurred in that 24 hours to go from 200 grams down to 12.5. So 200 grams and 1 half-life, 100 grams, 1 half-life. 2 half-lives, 50 grams. 3 half-lives, 25 grams. 1 half-life, 2 half-lives, 3 half-lives. I'm running out of word here is my problem. Let me come over here. I'll just write right here. You have 200 grams, 1 half-life, 100 grams. 2 half-lives, 50 grams. 3 half-lives, 25 grams. It would take 4 half-lives for us to get down to 12.5 grams. Well, it tells us that it took 24 hours to get down to 12.5 grams. So it took 24 hours to go through 4 half-lives. So what is the half-life of technetium-99? The answer is 8. No, 6 hours is our half-life for this isotope. So again, these are just all the different ways that you're going to use the concept of half-life, and the calculations really aren't that hard. You can get into more complex calculations with half-life, and you'll be doing that in your math classes. But for this class, we'll just be looking at things like this, and I like using the chart method. It works really well, and you don't even need a calculator. So we're going to practice this in class tomorrow. See you then. I'm not sure.